Every single day you perform a kind of miracle without even thinking about it. You take sounds, little scribbles, and gestures, and you turn them into these huge, complex ideas, emotions, and connections. It's the magic of language. So today we're going to decode that secret code and see exactly how your brain pulls it all off. So, really, how does it work? How does simple puffs of air or marks on a screen become, a declaration of love, a new scientific theory, or just your grocery list? That's the puzzle we're going to solve together, step by step. We're going to take a look right inside your own mind.
All right, so first things first, our journey starts with a language that's coming at us from the outside world. It doesn't matter if you're listening to a friend talk or reading a book, your brain has this incredibly sophisticated system for just grabbing it all and making sense of it.
So check this out. It basically breaks down into three key stages. First, sound waves hit your ear and get converted into neural signals your brain can read. Then, your brain identifies the absolute smallest units of sound. And finally, these specialized language centers, you might have heard of Broca's area for grammar and Wernicke's area for meaning, they get to work decoding the actual message. It's like a lightning-fast assembly line running inside your head 24/7.
Now, that middle step, it all relies on something called phonemes. Think of them like the atoms of sound. Just one tiny phoneme is the only difference between tap and tab. And what's wild is that while we humans can tell apart over 100 different phonemes, most languages build their entire vocabulary using only about 30 to 50 of them. That's it. But let's be real, we don't just hear individual sounds, do we? We hear words, sentences, entire stories. And for that to happen, your brain has to become a bit of a detective, using all the clues from the surrounding conversation to figure out what's really being said. To solve this puzzle, your brain is doing two huge things at once. Lexical access, which is kind of like looking up a word in your own personal mental dictionary, and semantic integration, which is figuring out how that word's meaning fits into the whole sentence. So if I just say the word bat, you have no idea if I mean the animal or a baseball bat until I give you more context. Your brain does all that detective work instantly. It's incredible. Now, for reading, there are a couple of big ideas about how this works. Bottom-up processing says you start small with the letters and build up to words and then sentences. Top-down processing suggests the opposite, that you use what you already know to predict what's coming next. The truth? Well, modern theories say your brain is a master multitasker. It's doing both at the exact same time to help you read as fast and efficiently as you do. Okay, so we've managed to turn sounds into words. Awesome. But how do we string those words together into sentences that actually make sense? For that, we need to go a little deeper, into the engine room of language, the hidden, universal rules of grammar. And this is where the legendary linguist Noam Chomsky comes in and basically turns everything on its head. He proposed this radical idea that the basic blueprint for language, what he called a universal grammar, isn't something we learn from scratch. Nope. He argued it's actually hardwired into the human brain right from birth. Now, the key to Chomsky's theory is this distinction right here. The deep structure, that's the core abstract meaning you want to get across, and the surface structure, that's the actual arrangement of words you use to say it. Here's a great way to think about it. The deep structure is the recipe, and the surface structure is the finished cake. Same core ingredients, but it can end up looking a little different. For example, take these two sentences. The dog chased the cat, and the cat was chased by the dog. On the surface, they look different, right? Different word order, but they share the exact same deep structure, the same core meaning of a dog chasing a cat. Your brain just gets that connection effortlessly. And look, this isn't just some abstract academic theory. No way. This idea is huge. It helps explain how we can create and understand a basically infinite number of sentences we've never even heard before. It gives us incredible insights into language disorders, and maybe most amazingly, it forms the foundational logic for the AI that powers things like Siri and Alexa. So, up to now, we've been focused on understanding language as it comes in. But what about creating it ourselves? All right, we're flipping the switch now from reception to production. And believe me, it is an incredibly complex cognitive feat. Oh, we've all been there, right? That super frustrating moment when a word is right there, but you just can't grab it. Or even worse, when you mean to say one thing and something totally different just pops out. Well, these aren't just funny little glitches. They're actually windows into how the brain works. These common speech errors are pure gold for scientists. A slip of the tongue or mixing up sounds, it's not random. It reveals these super intricate planning stages our brain goes through before we even make a peep, showing how we organize thoughts, pick the right words, and plan all the muscle movements to say them. And of course, spoken language is never just about the words themselves. The gestures we use, our tone of voice, the social situation we're in, all of that adds these critical layers of meaning that our brain is processing right alongside the words. Now, to really see this complexity in action, let's look at what happens when a brain is juggling not just one language, but two or even more. This is the amazing world of the bilingual brain. You know, being bilingual is basically a constant workout for the brain. A lot of research shows it can lead to some serious cognitive advantages, like a boost in problem solving and better attention control. But there can be trade-offs. Bilinguals might have a slightly smaller vocabulary in each separate language, or sometimes take just a split second longer to pull up a specific word. And you probably heard bilingual people do this. It's called code switching. Now, a lot of people think it's a sign of confusion, but it's actually the exact opposite. It's a highly sophisticated skill. It shows a really deep understanding of both languages and the social context, letting the speakers switch effortlessly to whatever the best word or phrase is for that exact moment. So, we've been on a whirlwind tour of the cognitive science of language. Let's pull it all together and really look at why understanding this process is so fundamental to understanding, well, ourselves. When you boil it all down, your brain's language journey is this constant three-step dance. First, you decode the raw data coming in from your senses. Second, you apply those deep, universal rules of grammar to find the meaning. And third, you assemble and express your own unique thoughts back out into the world. When you really stop and think about it, language is so much more than just communication. It's kind of like the operating system of our minds. It's the invisible architecture that makes society, culture, science, and art all possible. It is, in so many ways, what makes us human. And that leaves us with one last, really fascinating question. If the language we use literally shapes the way we think, then what's going to shape the future of our language? As technology and global culture keep evolving, how will our internal code, our most human trait, evolve right along with it? Something to think about. Thanks for tuning in.